Hello, mathematicians. We are here together today and we are starting lesson 16 in math. So in front of you, you need your pink problem set, lesson 16, it looks like that. So we are continuing on with what we worked on yesterday, which would be 2 and 3 digit addition with the algorithm. So if we look at our objective and our I can statement, we're adding measurements. And really when it talks about adding measurements, excuse me, the only thing that we're doing with that, just like we did our last lesson, is that we have these measurements here. So we just want to make sure that when we do our addition, that we are labeling with either milliliters, centimeters, grams, whatever it is that our label is for our addition. And so we're adding measurements using the standard algorithm. So that's just like we did yesterday, where we are adding with our column addition to compose larger units twice. And what we mean by that is that you might have to carry twice. Okay. So we have maybe your, well, we'll get into it. Okay. Our I can statements, I can add measurements using the standard algorithm. So just like yesterday, just like I said, though, we might be having to carry twice, and be sure to add that digit at the top that we carried over into our tens or into our hundreds column. Okay. So here's my recommendation for you today. Let me just do one with you. So I'm going to pick down here. So 600, will you do this with me right now? Okay. So 697 plus 138. So 697 plus 138. All right. So 7 plus 8 is 15. Good. So we have 5, carry the 1. All right. So in here I'm going to go 9 plus 1 first because that gives me a 10. So it's always good to look for 10s. So 9 plus 1 is 10, plus 3 more is 13. So 3, carry the 1. And then we have 6, 7, 8. So 835, and our unit of measurement there is grams. And then we'll go ahead and circle it. Okay. So this is what it means when it says we're composing larger units twice, is that we're just carrying twice. Okay. So, and this is, if you think about last year in second grade, all of your bundling of tens and your hundreds, and that's really what we're working on, right? So my recommendation to you is I want you to try this whole sheet on your own. And there's a couple different ways that you can do it. If you are feeling really confident, do this whole front. Do the whole front and then go back and check. And when you check, you don't need to sit there and watch the whole thing. You can kind of fast forward till I get my answer. And if your answer matches my answer, then you can fast forward to where I get my answer for B, fast forward to C. But if your answer is wrong, then you could rewind and watch my process to see where you made a mistake. Does that make sense? So go ahead and try it. If you are not feeling that confident, maybe try a whole row, A, B, and C, and then go back and check. Or if you're really just not sure of yourself at all yet, pause it, do A, watch my video, okay, check your answer, pause it, do B. So you can go one by one. So depending on your level of comfort and your confidence level with your math, with this addition process, there's a couple different ways that you can do it, okay? So go ahead, pause the video, and get started. Okay, boys and girls, so we are ready to check. So I'm going to start right at A, and I've got 52 plus 68. 2 plus 8 is 10. 0, carry the 1. 5 plus 6 is 11. Plus 1 more is 12. So 120 milliliters. How'd we do with that one? Good. So B is 352 plus 68. 2 plus 8 is 10. 0, carry the 1. And then I'm going to do 5 plus 6. No, 5 plus 1 is 6. Plus 6 is 12. 2, carry the 1. 3 plus 1 is 4. So 420 milliliters. And make sure that you have those labels on there, okay? I can circle it to show my answer. How do we do with that one? Good. So C is 352 milliliters plus 468 milliliters. And I don't know why I just put milliliters. We don't need to do that. But we'll just leave it there for now. 2 plus 8 is 10. 0, carry the 1. 5 plus 1 is 6. Plus 6 more is 12. 2, carry the 1 again. 4 plus 3 is 7. Plus 1 more is 8. So 820 milliliters. Did you notice anything about all three of those problems on the top row? Yeah, they all have 20, 20, 20. So 120, 420, 820. And then if we continue to look, this is 52 and 68, 52 and 68, 52 and 68. We just changed the hundreds. Good. How do we do with that top row? Good. Let's continue on checking. 56 plus 94. Okay, 6 plus 4 makes a 10. So I've got 0, carry the 1. And then for this one, I'm going to say 9 plus 1 because that gives me a 10, right? 9 plus 1 is 10. Plus 5 is 15. So I put that 15 right in front of the 0, just like that. So that gives me 150 centimeters. And again, I know that I'm going fast, but I'm assuming that we already checked it, or that you already did it. So please, no matter how you're doing it, make sure that you are working independently and then coming back and checking your work with me, okay? All right, so 506 plus 94. Make sure that the 4 is under the 6, that we have that lined up in the ones column. The 9 is under the 0 and the 10s, and then there's nothing there for the 5, right? So 6 plus 4 makes a 10. So 0, carry the 1. And I always circle that so we don't forget it up top. 9 plus 1 makes 10, right? So 0, carry the 1. And 5 plus 1 is 6. 600, don't forget that label, centimeters. Okay? How'd we do? Good. And the last one of that second row is 506 centimeters. Oh, I keep doing that for some reason on that last one. We don't need to put that label till the end. 506 plus 394. 6 plus 4 makes a 10, right? So 0, carry the 1. 9 plus 1 also makes a 10. 0, carry the 1. 5 plus 3 is 8, plus 1 more is 9. So we have 900 centimeters. And then I can circle it. Okay, nice job. Give me 2 thumbs up if you had that row correct. Good, and if not, that is perfectly okay, right? As long as we are, don't just change the answer. So if you got it wrong, don't just say, oh, shoot, that was 900. I put a 9 there instead of a 0. See where you went wrong, right? Because our brains, we're not learning anything if we're just changing an answer. So it is fine if we make a mistake. We make mistakes all the time in math, but that's how we learn, right? But we only learn if we go back and we look and see what our mistakes are. Okay, so we did G together, so we're moving on to H. So we have 345 plus 597. Okay, so we have 5 plus 7 equals 12. 2, carry the 1. 9 plus 1 is 10. Plus 4 is 14. 4, carry the 1. So I went to the 9 plus 1 to make that 10 first because that makes it easier to solve, right? All right, and in the hundreds, we have 5 plus 3 is 8, plus 1 more is 9. So 942 grams. Make sure we give it that label. How'd you do? Good, and the last one of this row is 486 plus 497. So make sure it's nice and neat and lined up. And then we have 6 plus 7 equals 13, right? So 3, carry the 1. I'm going to say 9 plus 1 again because I want to get that 10 first. And then once I know that 9 plus 1 is 10, I can add the 8, which gives me 18. 8, carry the 1. 4 plus 4 is 8, plus 1 more is 9. So 983 grams. Don't forget that label. How do we do there? Good work. All right, so if we look at J and K, so these are the funky little setup, remember from yesterday? So I hope that you remembered how we set that up yesterday when you did this one. So we had 3 liters, 251 milliliters. So we'll set these up with our labels there. Plus 1 liter, 549 milliliters equals. When we kind of put that line right there, it's like saying equals, right? Okay, so let's see here. I'm going to start right here, milliliters. Okay. And then I've got 1 plus 9, which I know equals 10, right? So 0, carry the 1. 5 plus 4 is 9, plus 1 more is 10. So 0, carry the 1. 5 plus 2 is 7, plus 1 more is 8. So that gives me 800 milliliters. Am I done? I have this chunk over here, right? So I've got liters, liters, liters. And 3 plus 1 equals 4. So 4 liters, 800 milliliters. How do we do that? Nice work. Okay, and the last one, let's check and see how you did. So I'm going to set it up again. So 4 kg stands for kilograms. 384 grams. 384 grams. Plus 2 kilograms. 467 grams. Let me just make sure. Such an easy mistake to get this problem wrong would be, or any of these, is if we copy it wrong. So since there was a lot to this one, I just want to go back and check and make sure I copied it all correctly. So 4 kilograms, yep. 384 grams, 384 grams, yes. 2 kilograms, yes. 467 grams. Okay, good. I did get it. But when I usually check kids over, most of the time, if they got it wrong, their process was usually correct. They just copied it wrong. So we just want to make sure that we're careful in the copying of it, okay? Grams, grams, grams. Then I've got 4 plus 7, which equals 11, right? So 1, carry the 1 up top. 8 plus 6 is 14, plus 1 more is 15. So 5, carry the 1 up top and circle it. 3 plus 4 is 7, plus 1 more is 8. 851. Am I done? No, I still have the kilograms. Kilograms, kilograms, kilograms. And 4 plus 2 is 6. So 6 kilograms, 851 grams. How did we do? Did anybody get that whole first page right? Nice work. And again, it is so fine if we made a mistake, as long as we are looking to see what our mistake was and we're understanding and fixing it. Okay, so as soon as you are ready, go ahead and flip it over and join me on the back. And what do we have on the back? We have some word problems, right? So maybe you want to start these out with me and then see if you feel comfortable to branch off onto these on your own, okay? So let's take a look. Number 2, Lane makes sauerkraut. He weighs the amount of cabbage and salt he uses. Draw and label a tape diagram to find the total weight of the cabbage and salt Lane uses. All right, so this would be RDWW, right? Because it's a word problem. All right, so he weighs the amounts of cabbage and salt. Draw and label a tape diagram. So there's actually no numbers in that problem. Where do I get my numbers from? Right here, right? So there's 907 grams for the cabbage, 93 grams for the salt, okay? And we want to draw and label a tape diagram to find the total weight of cabbage and salt Lane uses. So that's my task. Do we have a clue word there? Total, right? We want to find the total weight. Do we have equal groups though? We don't, because total could tell us that we're either going to add or multiply. But we know that if we're going to multiply, we would have to have equal groups, and we don't, right? So we have, if I'm going to make a tape diagram, because it does say to make a tape diagram, how many groups would I have in my tape diagram? 2, right? Because I have the cabbage and salt. Are they equal in size? I'm going to make one like way bigger than the other because the cabbage is way bigger than the salt. The weight is way bigger. It's not the end of the world if you don't do that, but I just think it's a good idea to represent my tape diagram to kind of match what I have. So the cabbage, I'm going to put a C right above here for cabbage, and it's 907 grams. And then I'm going to put an S for the salt, and it's 93 grams. And I want to find the total weight of the cabbage and salt. Okay, so what do I do to those two numbers? I'm going to add them, right? When I ask for the total, I'm going to add. So I've got 907 plus 93. Okay, so then I start with my ones column. 7 plus 3 is 10, so 0, carry the 1. And then in my tens column, I have 1 plus 9, which makes a 10, 0, carry the 1 again, and 9 plus 1 is 10. So I stick my 10 right there. Ooh, what number do I have now? I have 1,000, right? When I have a number in the thousands place, I need to place a comma, and I'm going to stick it right there. So we would always stick our comma if we start from the left, 1, 2, 3, comma. Okay, because there's 3 digits in the hundreds, and then when I add that 4th digit, that turns it into 1,000, right? So it would be 1,000. Make sure we label. What would it be? 1,000 what? 1,000 grams. Good. Let me go back to our RDWW and see how we're coming. We did our read, right? So I can check that. We drew our tape diagram. I'm going to check that. We wrote a number sentence, so I can check that. What's left? A word sentence. So I'm going to look at what I underlined. Draw and label a tape diagram to find the total weight of the cabbage and salt. So the, with a capital T, total weight. Spelling should be correct because it's coming from the problem, or if you're writing it with me right now, it's right in front of you, right? So the total weight is 1, 1,000, 3 zeros, grams. And I can put that G period for grams. And then I can check off my last W. Okay. All right, what do we think? Good? All righty, let's take a look at number 3. Sue bakes many muffins for the school bake sale. After wrapping 86 muffins, she still has 58 muffins left cooling on the table. How many muffins did she bake all together? Is this RDWW? It's a word problem, right? So RDWW. I'm going to see what else I can do with my read. So she bakes many muffins for the school bake sale. After wrapping 86 muffins, she still has 58 muffins left cooling on the table. How many did she bake? I see 2 clue words here. What do we see? After she bakes 86 muffins, she still has 58 muffins left. Left is a clue word that often signals to us to subtract, but I'm also seeing a clue word that says the opposite of subtract. Do you see that other clue word? All together. How many muffins did she bake all together? So let's take a look here. I'm going to start drawing my picture to see if that clears it up any for me. Because right now I'm seeing that it's telling me to, if I just look at my clue words and don't pay attention, I'm not really thinking about the problem, I'm going to be confused. So I need to dig a little bit deeper, right? So I'm going to check off the read. So now I'm going to do my draw. So I'm going to do a tape diagram again. How many groups would I have in my tape diagram? 2, right? Because she has 2 sets of muffins. 86 and 58, so close in size, but not quite the same. After wrapping 86 muffins, so I'm going to put there, she wrapped those muffins. She still has 58 muffins left. So she wraps 86 muffins and sticks them there. And then she still has 58 muffins left over here that are cooling and that are not wrapped yet. And I want to know how many muffins did she bake all together? What would I do with those 2 numbers? So even though it says left, that's not telling me that I'm going to subtract. It's just saying that, yes, she wrapped up 86 muffins, and then she has 58 muffins left over there. So sometimes we can pull clue words, but we have to dig a little deeper to see if what we're actually supposed to do, because I also see that clue word altogether, which I know tells me that I'm going to add. Plus, what are we doing on this whole sheet today? We're adding, right? It's not always going to be that neat where we are just adding all on a page. But in this case, if we pay attention, we see 2 clue words, but then we think, what is the question? What is the story problem actually telling us? She wrapped 86 muffins. She has 58 muffins left. So those are still there to wrap. How many muffins did she bake all together? So that means I want the total, right? So I'm going to add 86 plus 58. 6 plus 8 is 14. 4, carry the 1. 8 plus 5, 13. Plus 1 more is 14. So 144 what? Muffins. Okay, and I did my read. I did my draw. I wrote a number sentence. So what's left? My word sentence. So I'll go to my question that I underline. How many muffins did she bake altogether? She, with a capital S, she baked 144 muffins. And what goes at the very end of our sentence? A period. Okay. Are you ready for number 4? If you want to try it on your own, if you haven't been trying anything on your own, you can go ahead and then come back and check with me after, okay? All right, so we know this is RDWW because it's a word problem. Okay. The milk carton to the right holds 183 liters more than the juice box. So it's not saying that it holds 183 milliliters. It's saying that it holds 183 milliliters more than the juice box. Okay, so it holds 183 milliliters more than the juice box. What is the total capacity of the juice box and the milk carton? Do we see a clue right there? Total, right? What is the total capacity? Total tells me that I'm either going to add or multiply. In this case, do I have equal groups? These are not equal in size, so I'm not going to multiply. I would add. All right, so check that off. I have a tape diagram here. Okay, and then I have the juice box, which I know is 279 milliliters. And then I have the milk carton, which I don't really know how much that is yet, but I do know that it's 183 milliliters more than the juice box, right? So let me read it again. The milk carton to the right holds 183 milliliters more than the juice box. What is the total capacity of the juice box and the milk carton? Okay, I need to find the capacity of the milk carton first, and then it's asking me for the total capacity of the juice and the milk. We had a problem like this yesterday, right? Where we said that it was kind of tricky because our problem only had 2 numbers in it, but this actually ended up being a 2-step problem. And this is reminding me of that problem a lot, okay? So first of all, to find the capacity of the milk carton, I need to take the 279, which is the juice, plus the 183. And remember, that's not the capacity of the milk. It's saying that the milk holds 183 milliliters more liquid than the juice. So this is not, 183 is not the capacity of the milk. And if we really think of that, that wouldn't make sense anyways. If we said the milk is 183 and the juice is 279, that doesn't make sense because the milk carton is bigger, right? So if we think of it that way, if we think, does that make sense? So we have to add 183 to 279 to find the capacity of the milk. So 9 plus 3 is 12. 2, carry the 1. 7 plus 8 is 15, plus 1 more is 16. 6, carry the 1. 2, 3, 4. So 462 milliliters. That's the capacity of the milk, which I have right here in my tape diagram. So 462 milliliters. Now, I'm not done though, because it says, what is the total capacity of the juice and the milk carton? So what do I do to these two numbers now? I need to add those two numbers, right? So I've got 279 plus 462. Add them up. Look at my ones column. 9 plus 2, 11. 1, carry the 1. 7 plus 6 is 13. Plus 1 more is 14. 4, carry the 1. 4, 5, 6, 7. So the total capacity of the milk and the juice would be 741 milliliters. So that was one of those ones that kind of sneaks up on you, and we have to keep asking ourselves as mathematicians, does that make sense? Okay, let's see what I did here. I already checked off my read. I did my draw. I wrote 2 number sentences because that sneaky problem was a 2-step word problem. And the last thing I have to do is to write my sentence. So I go to my question that I underlined. What is the total capacity of the juice box and milk carton? So the, with a capital T, the total capacity is 741 milliliters. So if you tried this on your own, maybe you got 462 for your answer and you thought, okay, that's my answer. But then this is why it's important that we come back and check, because then Mrs. Gruel could say, that's the first step, right? And it takes our brain a while to get used to recognizing problems like this. So if we are fooled by this at first, that's okay, because we're not used to problems like these. So we just have to kind of stick with it, get used to looking at problems like these, and then these will become easier and easier for us to spot these tricky problems and then solve. So that is it for our lesson today. We were using the addition algorithm. I hope that we are getting better and better at this. If you already felt good, great. If we weren't confident yet, I'm hoping that we're feeling a little bit more confident. We'll continue practicing. We're also going to be hitting up subtraction next. So we'll be looking forward to that as well next lesson. Nice job today, kiddos, and I will see you tomorrow.